Students, this is the help video for the key questions of the Unit 6 study guide. We're going to go ahead and start with finger tracking and reading out loud. Put your finger right there. Now read this out loud with your finger on the paper. Mr. and Mrs. Crawley want to design a rhomboid flower garden in their backyard. The garden is to be surrounded by a brick edging consisting of 6-inch bricks. The diagonal lengths of the garden are 12 feet and 16 feet respectively. Find the length of the border of the garden. Number of bricks required for the border. If the bricks cost 75 cents each, calculate the cost of the border. You're going to do these steps on your own. I'd like you to filter, which means to highlight or underline keywords and numbers. Box the target question or questions. Draw the diagram, label the diagram, list the given information, and then cross it out as you account for it on the diagram or the list. Pause the video. Do that on your own right now. Welcome back. How did you do it filtering? I said it's rhomboid is important. Surrounded by brick edging. And each brick is 6 inches. We have diagonal lengths of 12 feet and 16 feet respectively. Here are our target questions. We need the length of the border. That's question number 1. Number of bricks. That's question number 2. And then ultimately the cost of the border, question 3. So the most important is a rhombus, which means you should have drawn all 4 sides. It's a parallelogram with 4 equal sides. So I got that word rhombus. Our ultimate goal is to find the brick border, which is essentially the perimeter. Question mark. That's our brick border. Each brick that we're going to put there is only 6 inches in length. That's part of our list. As each brick is 6 inches. And just for comparison, if you have a foot, that means you get 2 bricks per foot. You have 2 diagonals, a shorter one, which is 12 feet, and a longer one, which is 16 feet. Because it's a parallelogram, they're bisected. So I have 6 feet and 6 feet, 8 feet and 8 feet respectively. Draw a label list, cross out. Obviously, to find the length of the border, you have to find the length of a single side. I'm not going to do the math for you, except to point out one really important key factor. The diagonals are perpendicular. And if they're perpendicular, it means you have yourself a right triangle. At this point, you should be getting your right triangle toolbox out and figuring out how you can solve for that one side, then the perimeter, number of bricks, and the cost. Do all of that work on your own. Pause the video. Restart when you're done. B. Let's finger track and read out loud. Put your finger on the paper right there. Read with me out loud. See the regular polygons below. Extend one side of each shape to create a single exterior angle. Face the dotted lines. Now sweep the one exterior angle created and sweep the matching interior angle next to it. Using exterior angle equals 360 over n, find the measure of a single exterior angle from each of the regular polygons below. Then find the corresponding interior angle next to it. So, example, I'm going to draw an exterior angle by sweeping that. For this triangle, you already know what those angles are, but we're going to add them anyways. Angle equals 360 over n, which is 3. And we know that this angle right here is 120. And then you should notice, the most important thing for you to notice is the fact that the exterior and interior angles adds up to 180. So that means that angle right there is 60. You're going to follow the same process for every single image here. Make an exterior angle and the corresponding interior angle right next to it. Find each of those angles by finding the exterior angle first, which is 360 over the number of sides. The next one, of course, is a pentagon, etc. Complete this entire page and restart the video. Welcome back. This question here, I'm not going to answer it for you, but it simply says, what do you notice about a single interior angle and exterior angle of each set of polygons? You're looking for a relationship of one in and one exterior angle in each of these shapes. There is a relationship. What is that relationship? And you come over here. Let's read this with your finger on the paper. What is the number of sides? Stop right there. Put a giant N above that. Keep that in mind. That ultimately you're going to be answering that question, the N number of sides. In a regular polygon, remember regular means everything is congruent, in which the measure of an interior angle is 17 times the measure of a matching exterior. Find the number of sides of the regular polygon that the interior exterior angle relationship and look up what it's called for your work. So let's just define our terms. The interior angle. The interior angle is, that's an equal sign, 17 times greater than the measure of an exterior angle. Since the interior is being compared to the exterior, I'm going to make it easy. I'm going to say an exterior angle is simply going to be x. Notice it's not n yet. So my interior angle is going to be 17x, and my exterior angle is just going to be x. Using the relationship between the interior and exterior from the previous page and this little key right here, solve for the interior and exterior angle. Put those two measurements right there, and then you're going to solve for the number of sides. Pause the video, finish the page. C. Let's finger track and read out loud. See the rectangle H, I, K, K. H, I, K, K. The diagonals I, K, and JH intersect at point D. The measure of D by K is 4 times as large as by JK. The length of HD is 10. Draw the rectangle HI K and find all possible angle measures and round side and lengths to angles to degree. Step one is to filter. We have two diagonals that need a second one. DJK is 4 times as big as ID. And the length of HD is 10 centimeters. As you label, go ahead and cross it out. Those intersect at point D. I took care of that information so you can cross it out. Very carefully, trace and sweep D, J, K. D, J, K, trace and sweep is 4 times as big as IJD. So we have ourselves a 4x and x relationship here. The length of H to D is 10. Centimeters. Knowing this, find all possible side lengths. So you just keep asking yourself, what do you know about rectangles? What do you know about rectangles? And keep asking yourself that and mark everything you know to be true of a diagram. The most important thing would be obviously starting in that corner right there. Once you ask yourself, what do you know about rectangles? Use your quad family tree, mark everything on the diagram, and then find all possible segment and side lengths. You're going to see several triangles here, but the most important thing is do not overlap these big overlapping right triangles. Hint, hint. Show all your work on the right-hand side, all computations. Pause the video, do your own work. Problem D. Finger track and read out loud. In the diagram below, PQRS is a rhombus. SRJK is an isosceles trapezoid, and JKHI is a square. We got ourselves a rhombus, an isosceles trapezoid, and a square. That's 3 very critical pieces of information. The angle TPQ is twice the measure of PCP. SQ, the segment, is 24√3. AJ is 14. You're going to find all possible segment side lengths and angle measures. Round side lengths to the tenth place, which is the first decimal place. Angle measures to the nearest whole degree. Let's start simply by labeling what we know to be true. First off, PQRS is a rhombus. So now you start marking everything that you know is true about a rhombus. The most important thing is that there's a right angle there. Of course, that's bisected both ways. All 4 sides are exactly the same. Don't overlook the fact that these corners are bisected. You just keep asking yourself, what do you know about a rhombus? Then we're told that SRJK is an isosceles trapezoid. And what's true about that, of course, is that we have equal sides here. We also have congruent angles there and congruent angles here. And we're told that JKHI is a square. And mark what you know to be true right there, of course, it's a square. You're only given a couple measurements here. And that's the fact that T2 is twice the measure of TQP. Trace that very carefully. TPQ. TPQ is twice the measure of, so that's a 2x relationship, TQP. TQP. That's a 2xx relationship. Of course, you have yourselves a right triangle here. Use that information to solve for x. A couple other pieces. S to Q is 24 root 3, so S all the way to Q is 24 root 3. If we were to split that in half, because of the point P being the midpoint, 24 root 3 divided by 2, that's going to equal 12 root 3. So right here we have 12 root 3, 12 root 3. And K to J is 14. Which means if you have a square here, of course this is 14. All the way around, make sure you physically trace that. Alrighty, starting with that right triangle, find everything you can find by starting with X. It'll be pretty obvious what you'll be working with. Yet again, a right triangle. When you're working with the trapezoid down here, I recommend you put your fingers here and you move them inside. The fact that those are equal is going to jar something. And of course, because that's a square, you have additional right triangles right there. Find everything you can find, pause the video, restart when you're done. Question E. Finger on the paper, read out loud. Hot Wheels has been making die-cast models of popular cars for over 50 years. Below is both a picture of a 2000 and a corresponding Hot Wheels model. The length of the actual car feet. So that we actually label that. The model is only 3 inches in length. What is the scale factor used to size down the car to the model? This is technically a dilation problem. And when we dilate, when we change in size, we multiply. So we're multiplying by a scale factor, which we use called K in class. So we're asking ourselves basically this, to scale down to 16 feet. We're asking 16 feet times what scale factor gives us that 3-inch model. That's for you to figure out. Be very careful with this. Finish this, then restart. Problem F. It says use n minus 2 times 180 over n to find the measure of one interior angle of the following polygons for work. So in a 24 gun, we want a single interior angle. So that's going to be 24 minus 2 times 180 over 24. Once you do your plugins, you can use a calculator, although you're so smart. Let me show you how to do this without a calculator. Watch the magic here. That's obviously 22 times 180 over 24. Then what you do is you simply keep hacking away at it by factoring, because the key to multiplying is not multiplying. It's factoring. So I know 6 goes in 24 8 times. Excuse me, 6 goes in 24 4 times. And 6 is going to go in here 30 times. And you ask yourself, I wonder what else I can do. Well, I know 2 goes in here twice and 2 goes in here 15. But see, there's more I can do. 2 goes into 22 11 times. And now I'm down to 11 times 15. Ta-da! Look, Mom, no calculator. Try to do as many of those without a calculator that you can, unless you get a decimal. I understand. But really try to do as many of those as you can without a calculator by factoring. Finish this entire page. Find a single interior angle, and they're all regular, which means all the angles are the same. Pause the video, finish the page. Once you have these angle measures, now you're going to answer questions about tessellations. That is from lesson 6.8. So if you need to, get lesson 6.8 out and answer the questions below. Keep in mind, there's going to be some mathematical computations you need to justify your answers to these questions. Pause the video, finish this page. This one has a video you need to watch beforehand. It helps explain the concept of a glide reflection. So a glide reflection combined. That's the key word there, is combine. A reflection with a translation, along with the direction of a mirrored line. Glide reflections are the only type of symmetry that impose more than one step. Like if you take a watch this video here. So in a glide reflection, it takes 2 steps. You reflect something and then you translate it. So the finished product is not only reflected, but it's also translated. It's almost like footprints on a sand. Now you're going to take this 3 bullets and read them out loud very carefully. You're going to follow those directions. You're going to plot the original coordinates, your glide reflection number 1, your glide reflection number 2. Then following the properties there, you're going to calculate what would be the 20th glide reflection. Do that work on your own. Pause the video. Welcome back. Problem H. These coordinate proofs, it's really important that you take the time to actually read through them. Given, we have a quadrilateral FGHI. With F, negative 5, E, A3, H, 6, negative 4, J, negative 5, negative 3. We're going to prove, this is called a double proof. We're going to prove positively that it is a parallelogram. That's the positive. And then we have to disprove that it's not a rectangle. It is a parallelogram, but not a rectangle. So to accomplish that, you need to answer two basic questions. What makes a parallelogram? Parallelogram. Write out the OCD qualities. Then over here, match it with midpoint, slope, or distance, prove this quality. With midpoint, slope, and distance, prove that quality. With midpoint, slope, or distance, prove this quality. So match that up. Pause the video, write out the OCD, match it with the equations, midpoint, slope, or distance. Second question, ask yourself, what makes a rectangle distinct? Two distinct qualities, different from a parallelogram. In other words, what makes a rectangle a rectangle? Uniquely different than just a parallelogram. All rectangles are parallelograms, but not all parallelograms are rectangles. What makes a rectangle unique? I'd like you to write those two qualities here, and then ask yourself if you were going to prove that those qualities don't exist. Did you use midpoint, slope, or distance for that quality, or midpoint, slope, or distance for this quality? Those you hunt down yourself using the quad family tree. Go ahead and do your various combinations of midpoint, slope, and distance. Make sure that you are answering both the positive and the negative question. The positive is that it is a parallelogram. The negative, that it's not a rectangle. Make sure you address both those proof points. Pause the video, do your own work, and then restart. We are given quadrilateral ABCD. A is negative 1, 3. The coordinates aren't there. I highly recommend you put them on there. So A, go ahead and put your coordinates there. Negative 1, positive 3, 4, 8, B. C is at 4, 4. And D is at 1, 1. We're going to prove that first it's a trapezoid. And then we're going to prove that EF is a median, which is also the average of the bases. The median is the average of the bases. So first we have to prove it's a trapezoid. Then we have to prove that we have a median. And then we're going to prove that the median is the average of the bases. Go ahead and read the instructions right here. We're going to be finding the slope. You're going to be finding midpoint. And then on this side, we're going to be finding distance. Slope, midpoint, distance. Right here, of course, you actually average the bases and then take all those mathematical computations and explain the meaning of your math, meaning that you have a trapezoid and that there exists a median, which is also the average of the bases. Show the meaning of your math. Pause the video, do all the math, write out its meaning. Okay, the last one. We're going to use properties of trapezoids. Properties of trapezoids to solve for x. And then find all angles or side lengths as possible. So in this first one, you have an isosceles trapezoid. If you have two equal sides, you have two equal angles. So obviously in this case, we have angle equals angle going on here. Two equal sides, of course, still two equal angles. But notice there's nothing there to match the blues or the greens. But we do know this is true. If these are parallel, stretching out, then we have ourselves consecutive interior angles, which means they add up to 180. So if they're base angles, they're congruent. If they're consecutive interior angles, also called leg angles, because they're connected to the legs. That's a leg right there. Those are leg angles. Then they add up to 180. Use that to solve for the last one as well. Then, of course, these guys, notice you have two midpoints. So we know this is true. Median equals the average of the bases. Use that to solve for both of those. Find all side lengths. Pause the video, complete all 6 problems, recheck your work on your own, and then in classroom.